Elon Musk's new battery breakthrough that will rip the EV industry apart. Elon Musk, the tech billionaire we all know and love in our own way, has just made a startling announcement. He has recently announced that his company was able to make a huge breakthrough in the design of electric batteries, which has the potential to send major shockwaves in the EV industry. In this video, we will be tackling some of the most important questions about this new battery. For instance, what materials will this new battery be employing? Is the battery based on a completely new design? How hefty a price tag can we expect from this new battery? Does this new battery technology have the potential to make a major shift in how we buy and purchase cars? Will buying an EV be a new normal? Tesla's popularity with its consumers is incontestable. These electric cars provide their owners with great economy, ease of use, comfort, and a very smooth driving experience. What's not to like with any Tesla? But you will be amazed to know that Elon Musk is looking to make EVs more efficient by improving upon the battery technology used in Tesla. How does he plan to improve upon the existing lithium-ion battery? And why would having lithium-ion batteries lead to problems in the first place? Those are very good questions. Let's answer the second question first. Lithium-ion batteries, no matter how energy efficient, need to be replaced with the passage of time. This racks up costs for consumers. If the problem of battery replacement can be solved, it would mean that EV would usher in a new era of technology. Let's answer the first question now. Elon Musk has introduced manganese to cars produced in Tesla as a substitute for lithium-ion batteries. The results are nothing short of spectacular. The potential for manganese-based cathode batteries is immense according to Elon Musk. This technological find was a result of years of research into substituting nickel from batteries used in Tesla. When the announcement was made at the Tesla Gigafactory in Berlin, his employees asked him about his lack of consideration for graphene as a substitute for nickel in the lithium-ion batteries used at Tesla. This was an excellent question because graphene and graphite are one of the most commonly occurring element forms of carbon on Earth. As such, this would mean that the costs of raw material would drop down to negligible levels. However, substituting nickel-based lithium-ion batteries with graphene is not as straightforward as it seems. For one, graphene requires a complex process for manufacturing, which would result in increased costs for labor. EV's price would go up and its demand would shrink in the long run. Also, the production systems will need to be completely revamped to get up to the orders placed. For now, the longer-range vehicles will be based on nickel-based battery cells and shorter-range vehicles will use iron phosphate-based batteries. This is the direction which Tesla will be going for in the shorter run. Another strategic issue with the use of lithium-ion batteries is the cost of nickel. Nickel is expensive to use in EVs because it occurs rarely in nature. The materials that will substitute nickel have to be commonly occurring enough so that the manufacturing cost and eventually the retail price of a Tesla EV goes down. Nickel has become more difficult to find as of late due to the conflict between Russia and Ukraine. Since Tesla relied on Ukraine for importing nickel, its cost of acquiring necessary raw material has gone up indefinitely. These logical issues steered Tesla toward using manganese as an alternative. This is not the first time when Tesla would use manganese in its raw material for battery, mind you. Manganese was used in Tesla as part of the chemical process taking place in the batteries they produced. Engineers at Tesla noticed with time how easy manganese was to work with. Specifically, more volume of manganese could be used in place of nickel in the new battery without overhauling the whole production system. Research in scientific journals have also pointed out the viability of using manganese-rich cathodes for energy-dense battery solutions. Imagine the energy-dense battery cells derived by a manganese cathode, enhancing the life cycle of each battery at almost half the cost. Yes, you heard that right. Manganese will allow Tesla to cut its production costs by half and simultaneously increase the mileage. To achieve the dual goal of cutting costs and increasing the efficiency of the battery used, Tesla aims to combine manganese with dry coating technology. Dry coating technology was a technology Tesla borrowed from Maxwell Technology in San Diego. Unlike wet coating technology, which Tesla had earlier to design its batteries earlier, dry coating technology would allow the used amount of toxic solvents to be drastically reduced. Dry coating technology helps in doing that by skipping the traditional application of a chemical slurry. Tesla aims to bring the power of dry coating and manganese-driven batteries together to roughly generate 100 gigawatt-hours of power. This could mean that Tesla could eventually use this power to supply his own factories in Germany and Texas. Yet, one must always be cautiously optimistic. This new technology is far from being implemented today. Application of newer technology takes time and is bound to run through some technical issues. Tesla still does not have the capacity to make its own dry cell batteries. Yet, once this technology is fully implemented, it will completely revolutionize the EV industry and will make Tesla more approachable for customers who are looking to transition to fully electric cars. So, how do you feel about this new breakthrough which Elon Musk has just announced? Feel free to comment in the section below. Make sure to like the video and subscribe to the channel. Thank you for watching this video.